Okay. Hey guys, I'm Kevin, co-founder for Curio. We're a full-stack gaming company, and we're building Onchain games. And today I'll be talking about hyperscaling Onchain games. Cool. So to start, we have kind of the era one of Onchain games. We have games like Axie, and we have Dark Forest. I think Dark Forest basically kicked off the explosion for fully Onchain games, and this happened in around 2020 to 2021. And it was the first game that was built fully on smart contracts on Gnosis chain using ZK Snarks, and people thought it was really cool to be able to actually build a game on smart contracts, and people didn't really think this was possible before. So this was kind of, I would say, like the first era for Onchain games. But this era created a lot of problems that people set to solve. The number one problem is pretty much it was really slow to build these games on EVM smart contracts because there's a lot of details, but basically you have to write all this custom game logic in your front end, back end. You have to build your own indexer, and there's no kind of standard data structure or standards, I would say, to actually build these components for the Onchain games. And a consequence of that is basically these games have extremely weak composability. So even though people thought, oh, you could build plugins on top of Dark Forest and things like this, and in reality, no one actually did because it was extremely difficult to actually even understand the code and contribute to kind of the code base. So I think people started to dream about, oh, what if you could have games that interoperate between each other, but this was not a reality yet. And then we kind of have the era two for Onchain games. So I would say this is probably the past year. So in this period, basically, different teams started building smart contract-based game engines on the EVM and also Starknet. So the different teams building, including us, Lattice, Dojo from Starknet, and people were building these smart contract-based game engines. So a set of smart contracts game developers used to build these games. So this kind of solved a lot of the iteration speed problem that I highlighted previously. So people now could actually build these games pretty rapidly, and all these games are kind of running in the browser. Like Lattice had this Minecraft clone running on Optimism, and we built these strategy games over the past year or so. So it solved a lot of the problems from the previous year, but it also created even more problems. And yeah, these are some of the features I just talked about. So they're building these on-chain ECS-based game engines, fancy word of saying just a set of smart contracts. And this allowed basically for developers to kind of solve a lot of these problems. They came with built-in indexers, so once you write the logic in the back end in smart contracts, you didn't have to write them again in the front end, which is really, really nice. And then they came with a set of standard data structures, so game developers could actually reason through these code and potentially be able to contribute that. But most of these games are built in the browser and pixel art based, so they still feel like indie projects. And then this is like an overview of what an ECS system is. It's simply just a set of kind of standard data structures that all kind of game engines use to achieve high performance. And then at this time, we also built our own game called Treaty, launched earlier this year. So Treaty is a social diplomacy game kind of based on, I would say, like Civilization and all these sorts of related games where you play as a nation and you negotiate with other nations to achieve dominance and victory. And so we also launched this using our own kind of game engine built on the EVM. We were probably one of the first teams to adopt kind of, I guess, the app-specific chain thesis. So we had our own rollup running since like April 2022, I would say, which I think that idea is quite popular now with like Zora chain and all these sorts of L2s, like base chain. And then the core idea that we had for our game, which is also our attempt to answer the question why on-chain games, is the idea of using smart contracts as social contracts. So in this game, Treaty, different treaties represent social relationships between players. So a simple example of this could be two nations agree to not attack each other for a certain amount of time. So this sort of rule set would be enforced by EVM smart contracts. So that would be a really simple relationship. A complex relationship would be something like a nation kind of lends different troops to other nations. And if the other nation is in debt, then this nation can, let's say, take away a piece of land or take away some sort of ERC20 tokens. So we wanted to encode a lot of these relationships in smart contracts. And this is actually tangibly solving a problem that it happens in Web 2 games. Like for example, EVE Online, you have like 5 million players playing, but there's actually no way for people to kind of express these relationships. And the problem with that is basically whenever somebody's kind of like violating these oral agreements, there's actually nothing the other players can do to kind of punish them. Whereas obviously in real life, you have authorities that can enforce rules, and that's what makes a lot of things interesting. So this was our idea of kind of using smart contracts in a meaningful way to build strategy games. And this was not our game. We based this game on Civilization. So this is what Civilization looks like. And there's still a lot of problems with building Onchain games, and this is I think where we're at now, and where a lot of teams are developing these problems. So to start, there's a huge performance issue with actually building complex games. Even if you run a single node kind of L2 EVM rollup, you're going to run into complexity and performance problems if your game is really, really complicated, like Civilization or something even close to that. The second problem is fundamentally blockchain architectures are very different than game engine architectures. So blockchains are asynchronous by nature, and game servers are kind of synchronous by nature. So what that means is that for blockchains cannot update themselves over time. So you can't tell the blockchain to ping a smart contract function every block. So you have to use things like keeper networks like Gelato to actually like liquidate positions and things like this. Whereas game servers actively need to update itself every 20, 30, 50 milliseconds. So an example of this is if I select a group of armies and I want to move it to a certain direction, it needs to actually move over time, even if I shut down my browser or my game. So this is like an architectural difference that's fundamentally incompatible with blockchains that needs to be solved. And then there's still a lot of problems with actually writing code in Solidity. Even though we have a lot of kind of great tooling now with things like Foundry, this is still not great. It does not enjoy the first-class support as other kind of native languages. So and there's also just a lack of game-focused developer tools in general. So these are kind of the problems that we discovered, I think, around after building Onchain games since end of 2021, so for almost 2 years now. And we've set out to solve a lot of these problems, like Q1 2023, I would say. And to recap what a game tick is, you can think of game ticks as blocks. So this is how like a traditional kind of a game engine would look like, where you have clients that are sending these inputs to the server. There's a certain amount of lag, and then the server is processing these results and then sending all these results back. So this slice of time here would be one game tick. In blockchain terms, this would be one block. And usually this slice of time is something like 30 milliseconds in the case of Overwatch. But for blockchains, even if you run an optimistic rollup, you can at most get like 2 blocks per second because of the underlying constraints of a blockchain. So between 50 milliseconds and kind of 500 milliseconds is a huge time difference, and simply like Web 2 gamers will not be able to accept that kind of difference in visual experience. So this is like the kind of goal that we set out to build. We wanted to build an engine that combines the performance of traditional game servers with EVM smart contracts. We think that the most important kind of properties of Onchain games is the ability for players to write smart contracts, like modding them. So this is kind of the I guess mission statement that we have for our architecture. So we set out to build Keystone, which is our kind of flagship architecture. And this is fundamentally different from kind of other types of the game engines. Keystone is an opinionated rollup framework purposely built for high-performance on-chain games. And each game runs on its own rollup. So for example, now you see there's a lot of different kind of L2s that are popping up, like Zora or Base Chain, but all of them are basically OP stack forks. We think that fundamentally, like, down the line in the next like 6 to 8 months, we're going to see much more differentiated rollups. Because EVM is a great kind of medium for just running anything, but it's not specialized for actually anything in particular. And for games, this is simply not kind of reaching the performance that we need. So Keystone is setting out to be this very opinionated framework that will only work for games and nothing else. It will not work for DeFi or on-chain social or anything like that. It will only work for on-chain games. And there's a kind of a fundamental idea shift between smart contract-based engines and roll-up-based engines. So previously, we were writing smart contracts on top of Ethereum to build games. That's very easy and very straightforward. And then we ran into all these problems. Now we're interested in building kind of roll-up-based engines. So actually encoding a lot of the logic inside of the node software itself. So this is kind of like the, I think, big shift that we're making. And we're one of the few teams that's doing this in this space. And I think all teams will need to kind of adopt to this thinking if you actually want to approach the Web 2 audience, the mass consumer. And there's kind of two parts to our architecture. I can show a diagram later. So you can think about this sequencer design as there's two parts. There's one ECS core, which is the game engine. So this looks very similar to a traditional game engine where you have the code written in Go, and then it contains all the game logic and runs native code in parallel, so it becomes really fast. And it also has natively built-in game tick. So even if you're not touching the chain, it updates itself like 10 to 20 times per second, aka having 10 to 20 blocks per second. So this actually allows us to build like real-time games that you see in kind of any real-time strategy games. And it's also like a deterministic state machine. And to demonstrate this, like this is something we built. We basically put like World of Warcraft assets in Unity, and we ran the game, like a very simple game where you could attack each other on this rollup to demonstrate that I think Onchain games need to achieve this kind of sort of performance down the line. And then the second part of kind of the sequencer design is that we still wanted the ability for players to write smart contracts, and this is a bit, I guess, complicated to explain, but these two parts kind of interoperate with each other through a lot of kind of like EVM hacks. So players can still come into the game and write a lot of these treaties and submit these treaties into the EVM part of the game engine. We're still thinking about kind of which framework to use, but the two parts kind of interoperate with each other. So when you're writing a smart contract, you can actually read a lot of the logic from the game engine part through precompiles, and the two kind of parts of the stack can kind of trigger each other in asynchronous ways. One way to think about this is that this is basically a shared sequencer design with two different sets of rollups. One is the EVM rollup, and one is the ECS game engine rollup, and is rolled up into Keystone. So this is kind of like the high-level architecture on what we're trying to build. And I think this is like probably the more interesting slide is like, what are the interesting things that you could do once you actually own the chain, and once you actually own the infrastructure itself. So for example, what if you could have players, because we're operating in a setting where anything is in some ways acceptable if it makes sense to the game. For example, players could use like time travel spells or spend gas to rewind the chain. So a chain doesn't even have to go forward in time. It can maybe like, teleport back in time to reset the chain in some ways, or players could vote to pause the chain. Smart contracts also don't really have to be immutable or kind of stay forever on the chain by default. I mean, this only makes sense in kind of public blockchains, but in a setting of a game, as part of a game feature, you can have smart contracts that only last for a certain amount of time, and you have to keep on paying for these smart contracts for it to live on. Maybe you can also have tokens and pay gas to destroy smart contracts. So this also would not make sense on Ethereum, but it might make sense in the context of a game. So maybe a smart contract represents some sort of relationship between two players, and I can actually like pay some sort of ERC20 tokens to destroy that relationship. That could be an interesting feature. And maybe you could also have a feature that allows you to steal from other people's EOAs. So you could have like a socialism chain, basically like a communism chain. So that could be like a quite interesting game feature where people can vote to like purge other people's accounts. But this also just wouldn't be reasonable on Ethereum, but it would make sense on a very game-specific rollup. And I think the conclusion here is that we need to get creative with the EVM. And then if we're actually building a game that's aimed to be fun, we can rethink a lot of these kind of properties that Ethereum has or these rollups has, but games don't really have to have. Yeah. And then I guess I summarized a few lessons, I think, or like thoughts after building Onchain games for almost 2 years, which is pretty crazy. I think first, the industry still struggles to answer the question, why Onchain games? I mean, I think this is like the most important slide. And I think to us, there's kind of two parts. I think a lot of Onchain game teams kind of shy away from leading into a lot of these like token experiments, or they kind of like want to have this very purist view of what Onchain games and autonomous worlds need to be. But I think we think that tokens are like a great way to actually experiment with distribution, with retention, and once you add these high stakes into the game, it becomes a really good kind of testing ground for new game ideas. So we really need to lean into the kind of the tokenomics of just blockchain and the affordances it gives. And then the second part is like, how can Onchain games actually meaningfully kind of improve the game design of whatever game, in our case, strategy games. So we think that treaties represent one of the more interesting ideas, using smart contracts as social contracts, but there's tons of other kind of ideas that we could have on how that would actually solve a lot of the problems for Web2 strategy games. And then I think this is also really important, especially for L2s down the line, is that I think currently all L2s serve to serve basically a general audience, I think this is just simply not sustainable in the future. You have to know, I think, your audience extremely well, because L2s are supposed to be actually specialized and built with intention. So for us, because we're building for kind of more of the gaming audience, we can make a lot of trade-offs on the decentralization, liveliness curve to really kind of optimize for performance. But this also wouldn't make sense maybe for a DeFi specialized chain. But I think this is like one of the first questions you need to answer before you launch your own L2, which is like who you're actually building for, and then you can kind of tweak all these parameters to serve the users correctly. And everything is a means to an end. You're only building an L2 to serve your users, not just for the sake of building an L2. So you need to actually do that carefully. And then I think this is also related to the previous slide, is that you need to use the right tools for the right job. So I think Ethereum is incredibly powerful as kind of this neutrality layer and kind of arbitration layer for all sorts of things. But you actually need to kind of pick the right tool sets to use that correctly. So as for example, like one example is that, I think there's a lot of discourse around decentralizing your sequencers, but it really depends on who you're building for. If you're actually building for a gaming audience, it probably doesn't make any sense to actually decentralize your sequencers. And there's a lot of kind of unanswered technical questions from a lot of these like technical discussions that go on Twitter, but they actually don't really make a lot of sense if you think about who you're building for very clearly. And because you will know that, you can pick the right technical trade-offs. And you won't get psyoped into just using new technologies for the sake of using new technologies. So I think this is like extremely important. And then finally, I think there's a lot of kind of like open research problems on on-chain games. I think one of the more important kind of value props that people agree with is like, oh, you can have these mods where people can write smart contracts and contribute to some sort of game universe in a multiplayer way. But one obvious problem is like, how do mods kind of stay compatible with the game when it launches and when it goes on? What are the suitable economy models for on-chain games? So like traditional MMOs rely on basically the game developers issuing like inflationary assets to for developers to basically buy directly from the game store. This probably doesn't make sense for on-chain games, so we need to rethink that. How decentralized or permissionless do we actually need to be? So again, everything is a means to an end. For whatever audience that you're building for on-chain games, this is you have a very, very different answer. For example, if you're building an on-chain game for 100 whales that will spend $10,000 per month, then you probably need to be really decentralized and building on Ethereum, not an L2. But if you're building for the mass consumer and want to have 10,000 DAU with a very little kind of spend per user, then you probably don't care about the permissionlessness or decentralization elements. I think people just need to get honest about what are the actual trade-offs there and who you're actually building for. And also there's a lot of kind of questions around the end user experience. For example, do we play the game in the browser or do we play the game on the desktop or mobile? Do we launch on Android first versus iOS? What are the different kind of on and off ramps? And how can we meaningfully kind of increase the developer experience around on-chain games? So that's that. And then about us, we've been building on-chain games for around 2 years. This is like the first ever demo we built for our kind of, I guess, pre-seed, like way back in the day. And this is like a strategy game that we launched. And then we also had this kind of in-person demo at East San Francisco where people sat around the table and played a game. And then a little bit more about our team. We're about to hit a team of 10. A lot of team members come from Genshin Impact on the art side and engineering, and we raised the seed round led by Bain Capital last year. So yeah, that's it.
Thanks. Any questions here?
Could you explain a little bit about the roll-up, ephemeral roll-ups that you explained? Is that something based on any existing stack?
Yeah, so
you explained a few interesting concepts that you can have ephemeral roll-up, then you can have like rewinding states, destroyable smart contracts.
Yeah.
That's something achievable, but I just want to know that how does this work? Like, what do you use from existing stack, or is it completely new?
Yeah, so we've tried basically building this thing on OP-Stack. I've looked a lot into like EVM on Cosmos, Polaris, FMOS, like all sorts of frameworks we've examined, and I think like probably none of them actually fit what we need. There's a lot of optimizations that you can do on kind of the EVM side to make it go a lot faster. One example would be like you have a state tree under the EVM that's being Merkleized every block because you actually need to submit this block hash to other kind of validators for for consensus, right? But in a sequencer design, you probably don't actually need to do that. So
I'm more interested
yeah,
in the EVM. So
Yeah.
I see as a rollup as an execution environment.
yeah,
Essentially, that's an execution environment.
yeah.
So if you're doing it, you start using off-the-shelf EVM, or you have some additional breaking parts. So you want to consolidate.
Yeah, that's still too slow, basically. Like we've tried running this thing on OP-Stack. There's just a lot of overhead because OP-Stack is like the standard now. So it's like Geth plus something else, plus like 2,000 lines of code. It's still too slow because of a lot of the underlying constraints. For example, like game engines usually hold all your kind of state in your computer memory. So it has very fast retrieval and insertion and things like this. But for like OP-Stack, you're like storing things to disk like every so often, and it creates a lot of bottlenecks, right? So what if we could have an EVM that holds all the state in memory? So if your game is only running for like 2 hours, this is actually okay, and it won't be very expensive. But if you're building like an MMO, maybe you need to cache these objects like every 1 day or 2 days instead of like every 12 seconds like per block. So that's a very simple optimization that you can do that will probably speed it up by like a couple multiples. And there's a lot of other like optimizations you can do.
You could have parallelization there.
Yeah.
Saying that if you're using there's an underlying tree that you use for the contract states.
Yeah.
You don't really have to store everything on the node. You can have like parallel nodes, and then you can do that.
So for example, like one thing that I think parallel EVM is hard because in the traditional cases, like people really care about fair ordering. So people care about like, oh, if my transaction comes in first, then I can do that. But then in a game setting, like players probably do not care about like having atomic composability or things like this in a lot of cases. So you can kind of just fire forget and then parallelize a lot of the transactions. So there's a lot of like things that we could do there for sure. Yeah. Yeah.
So from a market point of view, do you
Yeah.
think that fully on-chain gaming is actually competing with the so-called Web 2.5 game, or like start a completely new kind of user base for them?
Yeah, I think depends on what type of fully on-chain game you're building. Like if you're building a fully on-chain game just for whales, which is like Wolf Game and all these sorts of games, then you're going into Web3 like degen audience, or like things like friend.tech. It's kind of like an on-chain game, and that's like highly profitable in that case. But if you're building for more of like a mass consumer audience, you're inevitably going to compete with I think like Web 2.5 audience. But I think like for us, we're starting with definitely the crypto native audience, because like that's where I come from, and that's where that's like where we know best, basically. And then once we hit PMF there, I think we'll slowly expand. So I think it really depends. But I think so far, most people are more interested in building like Forex whales. So they're building on like Optimism, Ethereum, things like this. So they have very, very simple games with very simple graphics, because these users do not care about actual experience. They just want to make money. But if you actually want to tap into kind of the mass consumer audience, then everything has to be right. So we're building our game in Unity with probably like some sort of AA experience with 3D graphics, like the whole immersive experience, because to that audience, it actually matters. So